get started. Welcome everyone. My name is James Serra. I'm a data and AI solution architect at Microsoft. Visit the sponsors. I mean, they're right out there. They're what make these events possible, so please go and patronize them and find out how they can make your life better. Usually a lot of them have some great products or services. A little bit about me. I've been doing this 40 years. I can't believe it's been that long. In my career, I've been everything from a database administrator to a developer, and I've worked on all sorts of products. SQL Server 1.0 back in 1989 is when I first started. And 9 years ago, I came to Microsoft, and I spend my days talking about data architectures with customers. And usually I do architect design sessions, whiteboard what the solution would look like. And that's what this presentation came out of, is my work with customers building or designing data architectures. And usually I don't talk about Microsoft products till the very end, like I'm going to do in this presentation. It's designed to be vendor neutral. I don't get into the products except for Microsoft Fabric. I'll talk with just a few slides in there, but these ideas and concepts that I talk about are relevant to any kind of solution that you're building, no matter what the products are. This came out of this presentation, a book came out of it, because I had so many questions about the architectures and the concepts, and I wrote a book that was just released. So if you want a deeper dive, and I'm not trying to make a sales pitch here, either order the book or just send me an email and I'll send you the PDF for free, since you attended. Especially the two people in the front row, they get special treatment. Yeah. This is the agenda. I'm going to talk about relational data warehouse and data lake at a very high level. I assume everyone here has a little bit of knowledge about what those are. And then I'll get into the four architectures: the modern data warehouse, the data fabric, data lakehouse, and data mesh. And I have to stress that these are my opinions. These are not Microsoft's opinions. So if you hear something here and you go back to your company and say, Microsoft said this, no, James Serra said this, because there's no official definition of all these from Microsoft in there. Now, most people at Microsoft agree with the way I believe in there, but there's nothing official about this as far as Microsoft goes. There's a lot to learn. This can get very confusing, and some people I see try to understand all this architecture stuff, and they wind up passed out drunken. So I want to prevent that from happening. Interestingly, this slide I've always had Denny's in here, but then I came here and I realized there's no Denny's in Poland. And then I used ChatGPT to say, what's the closest thing? And they told me what that is. I can't even pronounce it, but is that correct? All right, kind of. So let's try to avoid some of the confusion that you may have. And that's what we'll spend this hour doing. So the relational data warehouse in here, the idea at a very high level is I'm taking a bunch of sources, I'm using ETL, and I'm copying that data into a data warehouse from which I do reporting and analyzing. And the idea is to get self-service BI. A data warehouse is not OLTP, online transactional processing. It's for write once, read many. It's for reading, and it's for reporting on that, not an order entry system in there. Sometimes customers get confused about that. The whole idea is to try to make better business decisions and that. The more data you have, the better information you have, the more you can dig into it and make those better business decisions. You also will copy the data from your source systems, possibly many times inside the data warehouse or the data lake, as we'll talk about in here. There's this kind of misnomer that some of the architectures, especially data mesh, mean you don't need to copy the data, but that's not true at all. Some of these architectures, you will not have as many copies of the data, but you're always going to have to copy the data, at least once. And the reasons for using a data warehouse are many. I'll just talk about a few here. One of them is it becomes a single version of the truth. So you avoid having different answers for the same question, because the data warehouse becomes that golden source of truth. Also, it reduces stress on the production system. Think of if you're doing reporting and it's on some application, OLTP database, and somebody runs a malformed query, it takes up all the compute. The people who are using it for doing individual updates, deletes, and inserts get really angry. I was a DBA for about a dozen years. I became familiar with the kill command in SQL Server because somebody ran a query and didn't know what they were doing in there. So think of, at the very least, you're taking all that stress off of those production applications and production databases and instead doing it on a data warehouse in there. And that's probably the biggest reason in how data warehousing got started. There's also the ability to optimize it for read access. So some of you may be DBAs and you know I can put indexes on stuff. Well, there's always a trade-off. If you go on a OLTP database and you start adding indexes for reading, you're affecting people who are writing. And if I copy that data and send it to a data warehouse, I can put all sorts of indexes on there for read and not have to worry about influencing and hurting people who are doing writes. It's that one place to integrate multiple sources of data. A lot of times customers will have hundreds of data sources that they're integrating to help them make better business decisions. It also tracks history of people, as an example, of people that are customers and say you do a report at the end of the month and it's by state, and then a couple of months later you want to rerun that report. If you do that on the source system, those people may have moved, and so that report for previous is now inaccurate. With a data warehouse, you keep track through a history table of those changes, so the reporting is always accurate, and not to do what I see a lot of customers doing is saving these hard copy reports to avoid the problem of inaccurate reports. As a developer, I had instances where I'm creating a data warehouse, and the source system has tables like T102, T116, and imagine having somebody try to figure out what those are in order to generate reporting. Because the whole idea is self-service BI. So what you can do when you copy them into the databases and tables and fields into a data warehouse is you rename them so it's something that makes sense, and it's a lot easier for people to do self-service BI. Because the last thing you want to do if you're in IT is report writing. At least I was like that way. And so if you can offload that to the end users who know the data best by doing the work up front, which includes renaming the tables and fields, you're going to make them do the reporting and not have to rely on IT, which can become a big bottleneck. Think of and I've had this in a lot of customers where they had, say, Excel reports, and they're Excel, and they're running the reports against a source system, the OLTP database in there. And I've had cases where they've had hundreds of these Excel sheets, and the source system doesn't upgrade it, and they change the database names or the field names, the table names, all those reports break. Now you have to go in, and it wasn't fun changing and fixing almost 1,000 Excel sheets. What instead is hopefully you get away from Excel sheets, but even if you're using them, they go against a data warehouse, and if the application gets upgraded, what will break is the ETL copying it over. But the reports will not have to be changed. Now they'll be a little stale while you fix the ETL, but you just fix that and everything starts working again. So that's another big reason for having a data warehouse. Also, if I have a number of source systems and somebody wants to do reporting on all of them, I have to give them security access to all those source systems. If I copy that data and send it to a data warehouse, instead I just have to give them access to one place. So that can reduce the security problems you may have. You can keep historical data. The data warehouse can keep many years of data, where the OLTP applications databases may delete the data after a number of years. And okay, what happens if you need to go back and get that data? Well, the data warehouse, you'll keep all that data forever and not avoid that problem. If you create a data warehouse, it's the place where you can do master data management, or MDM. You can create hierarchies like company and division and manager and people like that. That can all be done in the data warehouse to make reporting easier and better. It can improve data quality in your source systems in there. I always saw customers think that their data is clean, and you start building a data warehouse and you find things like, the example I always use is birth dates. Why are these birth dates in the future, or somebody's 300 years old? Well, the source system required them to put a birth date in there, so they just entered anything because they didn't know it. And now you find all these problems. Now you still got to clean the data, but at least you can go to the people who have the source system and say, you have a plug, you got to fix this. and I'll only allow accurate birth dates in there. So you can do a lot of that. It's kind of a side benefit of data warehouse. And then lastly, as I mentioned, you want to have self-service BI. You don't want to have to be, unless you're one of those rare people that love to do reporting in IT, that'll be pushed off to the end users. All right, data lake. And by the way, I'll take questions. You just need to come up to the podium and grab a mic. No, I'm not going to let you do that. But I will be at the Ask the Experts at, I got to convert it in my head, 15:10. And so feel free to ask me questions there or catch me in the hallway, and I'll be glad to answer your questions. So let's move to the data lake in there. Data lake is much different than a relational data warehouse. A relational data warehouse is schema on write, meaning I got to do a lot of work up front. In order to put data in there, I got to create the database and the fields, schema, and tables, and then write the ETL. With a data lake, I can just go, it's like a glorified file folder. I can just go and copy and paste the file into there. And it could be any type of files or data in there. It doesn't have to be relational data in there. It could be structured, unstructured. And so, and everything has got a trade-off, but the great thing about the data lake is I can put it in there very quickly. And the benefits of a data lake are many. I just put 5 here. One of them is that you can get the data in there quickly, as I mentioned in there, and then that could open up the world for somebody to do a one-time report and not have to go through all the work to get it into a relational data warehouse in there. The whole idea is the barrier to entry is greatly reduced in here. I can start generating results quickly. And this has greatly improved the last few years with some of the new products. Because it used to be you had to be pretty technical to go and maybe write a Hive SQL query into data lake. Now the technology makes it so easy. And we'll get through the architectures where you're not even using relational data warehouse anymore. But the idea of a data lake is to have a much faster ROI because of the ease of use of putting data in there, how quickly you can do that. A really popular reason that people started using data lake about a dozen years ago was if I have a data warehouse, a relational data warehouse, I usually have a maintenance window. I kick people off at night. I copy data into staging tables in there. I fire up a lot of compute to transform all the data, and then I copy it into production, and then allow people back on. And cross my fingers that nothing goes wrong, or else you get there in the morning and you have all these angry people. At the very least, what a data lake can do for you is you take those staging tables that were in the relational data warehouse and you put them in a data lake. And you do the transformations in the data lake. So your relational data warehouse can run 24/7. There may be a very small window where you copy the data in there after it's been cleaned, but all that heavy work is done in the data lake. And when customers come to me and they say, our maintenance window's too long, we need people to do near 24/7, that's when a data lake can really, really help. The third reason here is the data lake is just storage. And there's a true separation of that in the compute. And what that means compared to a relational data warehouse where the compute and storage are married together and you can't do one without the other, with the data lake, I can have any compute I want, as long as that compute knows how to get data from a data lake, which is everything now. So I can fire up huge clusters if I want, and I can have that compute be everything from Spark and Databricks to some serverless SQL. It could be HD Insights for those that know what that product is, and all that can work to transforming the data. So I have a lot of extra compute. So maybe if I want to spend money because it's really important to transform the data, I can use that extra compute on there. So that gives you a tremendous amount of flexibility. The other one is because a data lake is so cheap, I can stockpile data in there. The cost for a data lake storage is extremely cheap, especially compared to the compute. So I see a lot of customers are going to say, well, I have this data from some IoT device. I don't know if it's useful, but I'm going to put it in the data lake and check it out later and see if it's useful. You would never do that with a relational data warehouse because you're limited on the storage and then performance problems, but a data lake, just throw everything in there because it's so cheap. And you can even save even more money by using certain features like with Azure and the Data Lake Storage Gen 2 has object tiering. You have hot, cold, cooler, and archive. So you can set data to be, spend even less on it just by moving around. And then finally, it can keep all the history of data. So even the data warehouse, you may come up with limits on how much it can hold because it becomes too expensive or you hit some level on there. So sometimes people will copy that older data into a data lake so it's still relevant in there, and they can have a view join data and relational data warehouse and what's in the data lake on there. You can use a data lake for a lot of other things, like I can back up data from a database in there and whatnot, but there's so many benefits to a data lake, and just really every company I deal with is, if they're building a data warehouse solution, they're using a data lake. So this gets us to our first architecture, the modern data warehouse, which has been around for about a dozen years. And at a very high level, this is what it looks like. There's 5 steps that you go through in all the architectures, and I name them ingest, store, transform, model, and visualize. Most other architects will have those same steps. They may call them something differently. But the idea is I'm going to use ETL or ELT and store this data in a data lake. At that point, for those that are technically astute, like machine learning data scientists, they can go and start using that data in a data lake right away. Now this is changing, you'll see, where everybody can go to the data lake, but go back a dozen years and only the people that had those technical skills would use the data lake. And inside the data lake, as I said, you transform the data with any kind of compute you wanted, and then you would take that data and model it in a relational data warehouse. You would copy some or all that data in there because it was too difficult for people to go into a data lake. And I remember the days when companies would say, hey, the data's in a data lake, it's in these files and these folders, and go use Hive SQL to pull it out. And they were like, you're confusing me. So they would copy the data into relational data warehouse, which the end users were familiar with. It was a nice model of data because the work was done by IT, and then from there they would use visualization and analytics. Having both a data lake and a relational data warehouse, I summarize at a high level the purpose for each of them. One of them, the data lake, would be the staging and prep area, as I talked about. It's also a great area to explore. You may see this data and you go, I don't know if this data is valuable, let me go look through it all. And I have the technical skills to do that in a data lake, and then I can see if it's got value. And if it is, then maybe at that point I copy it to a relational data warehouse because I know the questions to ask now and generate those reports and dashboards. The relational data warehouse was always this serving security and compliance layer because there's a lot of features that a data lake does not have. And one of them is security. For example, the row-level security does not exist in the data lake on that. So if you need that, you want to copy that data into relational data warehouse, as opposed to getting a large file that, say, has all these customers in there by department, and if only certain customers can see certain departments, you'd have to break up that file and put it in separate folders and give that special security to each of those folders. That's a lot of work compared to just copying all that data in a relational database and using a row-level security feature on there. And then there's a lot of other reasons traditionally that people preferred the relational data warehouse for serving. It had to do with speed of the queries. It had to do with concurrency. The data lake being a file-based system in there can't be as fast as a relational data warehouse. It can't support the concurrency. So this was traditionally the way in a modern data warehouse it was laid out to use both of the particular features of particular object storage, the data lake and relational data warehouse. Now, digging a little bit more into what that would look like is the 5 steps again. I have ingesting from all these sources. I'm doing batch ingesting, and then I'm putting it into a data lake. The data lake can have multiple layers in there. So if we think of the medallion architecture, how many people have heard of the medallion architecture? Okay, a lot of you. That's something brought up by Databricks, and I prefer to use something more descriptive, so I call it raw, clean, and presentation instead of gold, silver, and bronze. And every company is different in how many layers they have. Some have as little as 2. I've seen some that have 10 layers in there. It all depends on your size and the speed and type of your data. So data lake design could be a whole subject matter that I can spend hours going through, because it's not only the layers you have to think through, but then the folder structure underneath them. You don't want to have one folder with millions of files in there. So you break it out by day or by subject matter. You break it up for security reasons. You break it up for performance reasons and there. So spend a lot of time understanding the data lake and how you want to design it, not just for the data you have now, but the data you have in the future. And again, it's just a storage, so you'll have that compute on top of it. And you could do things like have a sandbox. Maybe a data scientist person says, I want the data and I want to write it and combine it and aggregate it. Okay, I'll just create a sandbox for you. It's sitting in the data lake and there. And then the data is copied into that relational data warehouse. Now you may start out copying it in third normal form, and then from that third normal form, to make it easier for end users, you may, everybody know what that is? Star schema. How many people know what a star schema is? Wow, I have a great audience. They're really good here. I'm saying that to get good ratings for this. So the star schema is a way that you can organize the data in the relational data warehouse. Now, step 5 is where we visualize, where there's a lot of different approaches you can take. I can do a relational data. I can do a star schema within the RDW, or I can do that within Power BI if that's the tool I'm using. Maybe I don't even need a star schema, or maybe I can skip the third normal form. So there's a lot of ways, and that's where I talk with customers and ask them a lot of questions, and then we come up with the best approach. And then there's always the exceptions or data, because I had this question when I did a workshop yesterday, is sometimes you may want to skip the data lake. Just a relational database table, maybe a small one will go right to RDW. So there's all sorts of exceptions. Just know what the trade-offs are when you bypass something like the data lake. All right. So hopefully you've got a bit of an idea of the modern data warehouse now, and some of you may even be using that. I saw in the poll, and thanks for filling it out, that there was a modern data warehouse more than anything on there, and so that was interesting. Although Data Fabric was pretty close second, and now we move on to the Data Fabric. Now this is my definition. Not everybody agrees with this, and it's interesting. When I was writing the book, I was like, well, let me go and find out what the true definition of Data Fabric is, and everybody's got different ideas. So I go, well, how do I know what to put in the book? And I just said, well, I'm just going to put what I think it is, and I don't know if I'm right, and it doesn't mean because I wrote a book that everybody should use this, but at least it's a starting point for have discussions on there. And understanding what these architectures are, even though you may not agree with them, it gives us a way to start and have that healthy discussion. And the way I think of a data fabric is it's a glorified, or it's an evolution, I should say, of your modern data warehouse. It's giving you additional functionality to, as a data fabric does, weave out and pull in more data sources, no matter what the size, the speed, or the type is. So it'll add functionality, including things like data access policies, which is just better security. It'll have functionality with metadata catalog. Maybe it's using something like Purview in there. It'll have master data management in there. It may use a data virtualization component in there. It will have real-time processing. The modern data warehouse I showed you just had batch. This adds another layer of streaming data in there. It could have APIs, which are used for pulling data out instead of a connection string. Sometimes, not a lot, but a handful of companies that I work with are creating APIs. And you could also design it as building blocks, meaning maybe somebody within my company says, oh, I like that data fabric, but I really can't, it's really not useful for me, but you've created this ingestion piece that's really awesome. Can I use that? And if you build it out in a certain way, where it's generalized or using configuration files in there, that could be a building block or a service that people can use. And then some companies have whole products on the data fabric in there. And And so what I find is a lot of times this is an evolution of the modern data warehouse, and people will just use data fabric. They won't use MDW anymore. They'll call everything a data fabric. If I dig into this a little bit more, the features in purple are what I have above what an MDW has. So we have the metadata, MDM, event security, and APIs. And if we dig a little deeper into what that looks like, you can see now I have ingestion piece in here for real time, in addition to batch. I have more security over my data lake. I have MDM component in there. I have API calls in there, and I have a metadata catalog. And this is very common. The last few years, with the next architecture, data lakehouses has become more popular. But a data fabric, and I'll summarize this at the end of when you still may use this. My definition of data fabric is much different than Gartner's. Gartner has what I call the intelligent data fabric. There is a lot of automation in theirs where it's, hey, somebody puts a new data source in your environment and it automatically goes and finds the data, cleans it, writes the ETL, and puts it in a data lake. But there's no technology that does that yet. So that's why I say it's a great idea, but we're not there yet. And they also use knowledge graphs and other things that I just see that's not common. Now, it's still good to learn about what Gartner has as their thought process of intelligent data lake, or data fabric, but you just won't find the technology for it yet. I think we're getting there now with generative AI. You may see the ability to go and find things, but we're just don't have any products for that yet. All right, data lakehouse. A little bit of history for those of you that are as old as me. You'll remember the days in the 80s of products like Teradata and Netezza, where they're all encompassing. There was a relational data warehouse for large data. Large data back then was like a gig. And we didn't have internet, if you can believe it, back then. And the product, like a Teradata, had relational storage, relational engine, had reporting tools, it had the ETL, it was all encompassing in there. Great product, still around, mostly for migrations to the cloud, but it did its job for a long time. And if you know the Kimball and Inman debates, there was the idea of creating data marts inside of that as a separate copy of the data, sometimes as a logical data warehouse. That's a whole other discussion, but what came out in the late 2000s was data lake. And there was a handful of companies that talked about Hadoop solutions on-prem. This was right around cloud time, was starting to get popular. Was not popular yet, it was starting to get popular a few years later. And so the idea was, hey, we can get rid of our relational data warehouses, we can put everything in a data lake, and it's this magical land of unicorns and fairies and what do you have, gnomes here, or dwarves that they have around? They were in here, and they were making all this easy. Well, that failed miserably because the data lake technology was just too hard to learn. And I have personal experience with two companies, and I'll give one. And apologies for those, if you were in the workshop, it's a repeat of the story, but it was where a company came in and they said, oh, this data lake stuff sounds great. We want to get rid of our relational data warehouses and build a data lake. And we can save a lot of money, can make our life a lot easier. And I said, that's not really a good idea because the data lake is very hard to use. The technology is just not there for an end user. I mean, end users hate change to begin with, but now you're making their lives even more difficult. And they said, we don't care, we're going to go down that route. So I talked to them about a data lake and a data lake design and whatnot. And then 5-6 months later, they came back, that group. And I said, oh, what are you doing here? And they go, yeah, that whole data lake thing didn't work out. They fired the CTO whose idea was it is, and now we want to go back to using a relational data warehouse. And what happened was people didn't say no more data lake. They said instead of the data lake doing everything, transforming and reporting the data and querying the data, we're going to do what it's best at and what's easiest to integrate an environment, and that's what we just talked about, the modern data warehouse and data fabric. So they just started using a subset of what the data lake did. and kept that data warehouse as that serving layer and security layer. Well, around 2020, Databricks came out with the idea of a data lakehouse. It's a data lake combined with a data warehouse to form the cute term data lakehouse. And their idea was you don't need relational data warehouses. And you should be going, oh, wait a minute, you just said that failed. What's the difference? Well, the difference now is Delta Lake. And that was technology that when it first came out, I said, maybe you can get away without having a relational data warehouse. I had touted and blogged that you'd always need a relational data warehouse, but then when I saw Delta Lake, it started changing my mind. And the reasons for that was Delta Lake has a lot of additional features to make the data lake relational data warehouse like. It's not its own storage, it's just a software layer on top of a data lake to give it some really cool features. One of them is SQL support. In a data lake, it doesn't know what SQL is. With a Delta Lake and putting things in a Delta Lake format gives you the functionality to do individual inserts, deletes, updates, and the merge statement on that. So that's where you can say, well, I can make it somewhat like a relational database in there. It supports ACID transactions, which was a big problem. If something blows up halfway through updating a table, this gave you the ACID support for a table because underneath the covers, when you write data into a Delta Lake, it's as a simple matter as instead of saying I want to write it in Parquet format, you just say I want it in Delta format. Underneath the covers, it writes it in Parquet format, but it splits up large files into multiple Parquets for performance, and then has a Delta log table that keeps track of all the transactions that are being done, like a transaction log within SQL Server. So that's what it gave it the ACID transaction support. It also supports time travel because it's keeping track of those transactions. You can use that for rollback and auditing, or you can say in a select statement, give me this, here's the select statement as of a particular date in the past, and it'll give you the older data on that, which is a really cool feature. And then it was a great place to do both streaming and batch. So instead of having completely different environments to do both, you could do all of that with Delta Lake. And it has things like schema enforcement and evolution, so you can prevent somebody from putting, say, a CSV file or a Parquet. You can convert, say, a CSV or JSON into Parquet and land it in there, and you can have schema enforcement. So if somebody tries to put a Parquet file that is much different than everything else in there, it will kick it out. Otherwise, you run ETL and it'll just blow up because it's like, well, I don't know what this is. So kind of cool features in there. Now, this is a little tricky because if you start doing that, then you're becoming more of a schema on write because you got to define what the format looks like. And that's a big difference between schema on read and schema on write. Schema on read means when you pull it out, you have to get the schema on that. And this is kind of a go-between. You're now defining it before you pulling it out. So I always want to bring that up because people get confused about that. And it has a lot of performance improvements. There's like a dozen of them. So it can make it much, much faster than a data lake because they've done things underneath the covers for those performance enhancements. And then for those of you are aware, when you have a lot of files that are constantly updated, you can run into small files problems, and this could solve this through this optimize command where it combines all the files in there. When you have data and you're putting it into a Delta format, all the files are immutable. So if I do updates, it's not really actually updating that one file, it's adding to it. And you can have a bunch of small files if you're doing a lot of transactions, and that can cause performance problems. This could combine them all with an optimize command, which was very new when they first came out with it. So what does this look like at a high level? You can see I have everything just like the data fabric, but I've removed the relational data warehouse piece of that because you only need one copy of the data now. So what are the use cases for this? One of it is that it solves 6 problems. One of the problems it solves is if I have 2 copies of the data, I have to keep them consistent. What if my ETL breaks between the two? That causes problems. Well, I have 1 copy, so I don't worry about that anymore. if I have those 2 copies in there, that relational data warehouse is always going to be older. Even if it's just an hour and 15 minutes, it's going to be older than what's in the data lake. That can be a problem. That goes away because 1 copy of the data. The data scientists generally prefer files and folders in there, so you're making them happy. Even though storage is very cheap, you're saving 50% off because you only have 1 copy of the data. And reducing the copies reduces the security risk. And if I have both those technologies, I need to hire people that either know both or experts in both of them. I can do away with that and just say I need experts just in the data lake in there. So it's reducing the complexity to save costs. So what would this look like if I dive more into it? You can see it's very much like the data fabric, except I have replaced the relational data warehouse storage with a serving layer. And that's still important because you don't want to tell end users, hey, everything's in a file and folder format. You want to present it to them that's much easier for them to make sense of the data. And so that could be anything from a SQL view that's pointing to files in here that has the metadata in there, and people can look at it and think, oh, this is a relational data warehouse, when it's actually not on that. Now that object, there's a lot of things you can do with relational server layer. It could be semantic model in Power BI that's pointing to it. Now with data fabric, that semantic model is really easy to create on that. So it's just making the lives of the end user easier, because if you replace the traditional relational data warehouse and their interface to that world completely changes, you're going to have problems in there. So you'll have some serving layer on top of that. Now, everything's got trade-offs, and that's a big reason why I did the book. Was people were touting these architectures like a be-all, end-all, and you just use it, and there's no trade-offs. Well, there is a lot of trade-offs to it, and there's a number of them. If I say I'm not going to use a relational data warehouse, if I'm going to do everything inside of a data lake, it's going to sacrifice speed. How many people here know what massive parallel processing is, MPP technology? Ooh, this is the smartest audience ever. I got to come more often to Poland. It's very, very smart. Usually nobody knows what that is, but MPP technology in the Teradatas and the Teasas. When I first joined Microsoft, there was a thing called Parallel Data Warehouse. I won't go into it, but it just greatly increases the speed of your SQL engine. So you have that technology in a relational data warehouse. You also have indexing and statistics and caching and query plan optimization, materialized views, all these things that don't exist in a data lake or a Delta Lake. So I'm going to sacrifice some speed. Now, this is all relative. If the queries only take 3 seconds in a Delta Lake, that's fine. But if you say I need millisecond response time, then that could be a problem in there. And the whole idea is you go through these, and there's workarounds for them. You want to make sure that you know what the trade-offs are before you dive into it, and that you're okay with it. But at the very least, it's not an all or nothing, meaning if I have all this data and everything is fine except for this one particular data set, that data set can be copied to a relational data warehouse to solve the speed problem, where everything else can stay in a data lake or Delta Lake. The other concern is security. I mentioned there's no roll-up security, column level security, dynamic data masking, and so how do I get around that? Well, one of the ways you can get around that is I can copy the data into Power BI and use roll-up security in there. Now, if you come and say we're not using Power BI, then okay, that's not going to be a workaround on that. But generally, with most customers now, with the newest products in there, most of these things on here are either gone away or we do have a workaround, but not everything. There's a forced metadata layer. If you think of a relational data warehouse in there, you have to have the metadata. You have to have the tables and database field schemas defined, and then the data. In a data lake, or even Delta format, where is the metadata on that? I can in my data lake, I can have a CSV file, and maybe the header is the metadata, or maybe there is no metadata, or maybe it's separate. You're not forcing it. So that's the problem. That could be a big problem in there. So you have to have sort of best practices of putting the metadata with the data, or else the end user is going to be like, I have no idea what this data is. There's the file-based world, as I hit on, that could be very confusing for end users. And concurrency can be very slow in a Delta Lake if you're having hundreds or thousands of users hitting it, a certain file. That's just not going to give you the performance you would get from a relational data warehouse where it's been around years. SQL Server can support 1 million transactions per second. You would never get that in the world of a Delta Lake. Now, in most cases, this is a data warehouse. I don't need that concurrency, so that's usually not a problem, but it's just something to be aware of. And then there's a lot of missing features. Things like reference integrity don't exist in the Delta format. So what do I do? Well, you put that in code then. So that's a workaround. Now, maybe for some people that's a big problem, maybe others not. But you need to know that that doesn't exist. SQL views, data retention policies, all this other thing. And the big one is asset against multiple tables. That's a big point of surprise for many people who start building solutions. They don't realize that there is asset compliance, but it's only for one table. So if you need a begin transaction and you update a bunch of tables and end transaction, you can't do that with Delta Lake. That would have to be a SQL engine for that. And then, obviously, products need to support Delta Lake. And all the Microsoft products do. Delta Lake's not the only software layer on top of a data lake. There's Hootie is another one, and Iceberg is another one. But Microsoft has standardized on Delta Lake, mainly because Databricks came up with it, and we want to play nice with Databricks. And as I said, most of the new technology addresses all this. So just be aware of it and see if it's going to be a problem when you're building your solution. All right, data mesh. And I'm going to ask, even though I gave this, how many people who think they have a decent idea of what a data mesh is? That's more than usual. Now, and the really big question, and answer honestly, how many people here have built a data mesh? 2, 3. All right. Very smart audience because, and I'm being honest, I've never had anybody raise hands before. So now I can't say, nobody's ever raised their hands before when I ask how many built data mesh. I'll have to say Poland are a lot smarter than the world. It's 3 people. Now, we'd have to sit in one-on-one and talk about what your data mesh is because people have a lot of exceptions to a data mesh. And sometimes at the end of the day, I look at what they built, and I'm like, this is not really even a data mesh. Oh, well, we want to call it a data mesh. Okay, we'll call it a data mesh, but it's really a data lakehouse, but all right. So data mesh, and it's a very hard topic to understand, and Jamek Dagani, big credit to her. She had great blogs on this. The concepts weren't new, but they were organized really well, and if anything, it's got people talking, and we'll get into the principles of it, but it was great that she wrote that and allowed me to write a book about it. But I found, quite honestly, it was very confusing to me. Maybe because I got a simple mind. So I had to reread her blog many times and her book many times. And I finally said, this is it in a nutshell. Everything I talked about is centralizing the data. I have domains that could be organizations within my company. They're all sending their operational data into a central location where IT owns the data and then creates analytical data. Data mesh is each of the domains that have the operational data. You say, don't send me your operational IT. It's going to say, don't send me your operational data anymore. I want you to create the analytical data and make it available for everybody else to use. So you're pushing down the work to the domains. And that leads to, you'll understand the 4 principles, but that's it. That's the big difference. There's no centralization. All of it is, the work is done by the domains. And the big thing to understand is a data mesh is a concept. It's not a technology. I struggle to even calling this an architecture because those domains here can build out the solutions using a data lakehouse, a data fabric, or MDW. So it's not mutually exclusive. But it's a big, huge cultural shift, and that's the problem where a lot of people don't implement data mesh. It's too much of a change. It's basically, and it's a lot of hype, It's not something you can go buy on eBay. And if any vendors are out there saying they have data mesh in a box, tell me, I'm going to go and talk to them, because anything you're going to build in a data mesh will take you much longer than any other technologies, unless they come out with that magic wand. And that's actually a pretty good price. Here it is in 4, hopefully easy to understand principles. Principle number 1 is domain ownership. You're just saying all the organizations in your company, manufacturing, sales, supplier, those are domains. They will own the data. So no arguing if it copies over the IT, who owns it. You're not copying IT. So the end users, the domains own it, which means they're going to clean it, and at least in theory, the data quality will be a lot more clean because they know the data best. You're going to tell each of those domains to treat data as a product, means they are, first off, going to have their own IT teams, and they're going to have their own infrastructure, and they're going to write their own code to create the analytical data and to make it available to every other domain or consumers. Maybe they make it available through an API call, a bunch of them, that they have to build it all. Now that's a lot of work. So how can we shortcut these domains building the solution? Because there could be dozens, if not hundreds of domains. Well, that's what principle 3 and 4 is. One of self-service data infrastructure is a platform. The idea is, ideally you have a script, you click a button, it says what's your domain name, and it go and builds it all out. It builds out the storage, compute, ETL, security. Right? There's no product that does that, obviously, not even close. Most customers I deal with, they build something like that from scratch. They write all these scripts in there, and in the end, they're making it easier for those domains, at the very least, to not have to reinvent the wheel. And then, along the same lines, 4, federated computational governance is, we don't want all the domains defining different security methods on there. We don't want them cleaning data differently. We don't want them modeling data differently. Imagine if one domain's using a certain type of security and another's using something completely different, and I got to combine all this data. Or even something simple like they're using codes for states, and they're using 2 digits. Other ones are using the full name. Now you need to combine the data. You have all these problems. So the idea is a team will create global rules that all the domains have to follow, like a playbook for them. Some people even call it contracts that they got to follow. So those are the 4. Now the confusion is, people think data mesh is all decentralized. Well, the reality is only 2 of those principles are decentralized: the ownership and data as a product. The other 2, there's going to be a centralized team that's going to do that. Now that centralized team could be made up of individuals for each of the domains, but you can't decentralize those. It goes against the whole idea. So 3 and 4 are going to be centralized teams. So what does data mesh help? What are the 4 challenges it solves? 2 of them are lack of ownership and lack of quality. Domains own the data, no argument there. They're going to clean the data, and they know it best, so the data quality will be better. The 2 biggest reasons for data mesh, though, are organizational and technical scaling. If I have more domains, each of them hire people to build the analytical solution. More domains, more people. I'm scaling out. I'm solving the organizational problem that you have with IT doing everything, because IT has a limited amount of people. They become a bottleneck as more data requests come in. Also, technical scaling. Central IT has a solution they built that's got limits on the architecture and the technology in there. If domains have their own infrastructure, more domains, more infrastructure. That solves the technology problem. That sounds great, and if we look at the domains, this is the way we split it out as an example of healthcare company. It could have, usually they have dozens of domains. Each domain has a bunch of products in there. This is where it gets really difficult, because I can take months. I've seen customers take months to define all this. Then you have to go around and tell all the people, we're moving everybody around to fit into these domains. People, again, don't like change, so that's a big problem a lot of customers had with going down this route of using data mesh. And what can happen then is you have source-aligned domains, but Jamek encouraged having also consumer-aligned domains, because what happens is the supplier domain could be easy for people in supply to know what it is, and understand the terms, but too difficult for people outside suppliers. So you can copy the data into a consumer line domain and make it easier for those consumers or other domains to see the data or understand the data. You also may have an aggregate domain, because if I try to combine the data from multiple domains, it may be very slow performance-wise, so I can create an aggregate domain. Now, I had a big problem with this, because to me, this is then asking the question, well, who owns this? And this is going against the scaling, and it's kind of going against the whole data mesh idea. So this gets very complicated also, because you have domains that are pulling data from other domains. So imagine how difficult this is already. Imagine you have 100 of these things. So another layer of complexity. So what you wind up having is a lot of concerns with a data mesh. I know I sound like I'm bashing a data mesh. Maybe I am, but when I first heard of the data mesh, I said, this is awesome. I started thinking through, well, we've had these conversations before many years ago when we Kimball and Inman debate and decentralization and centralization, and then reading everything, which sounds great in theory, but then I had concerns listed here. And these are only a handful of them. I have many more. But things like domains don't want to wait for data mesh. So imagine you're a domain, and you're sending all your data over to IT, and then IT says, stop sending it. Go and create your own reports. Hire your own team. Find the money. Build them out. Anything else you wanted to do, you have to wait, because now you're building this data mesh in there. And in the end, you're going to wind up having the same reports that IT gave you. So please go and do it. And then you're going to go like, well, why should I do that? And if the answer is for the greater good, how many of you would say, oh, okay, that makes sense? So that's a lot of pushback you get on that. A lot of resistance to data mesh for that reason alone on there. But data quality engineering people, I know there's a lot of smart people here. You're all smart. Let's go there. But there's not, in the world, it's hard to find really good data engineers. So now all these domain teams, hey, it's great organizations scaling, but they're going to go like, I've never hired engineering people before. Now you want me to do that? And trying to find them. And now they're going to go, and all it takes is one person in the mesh to do a really bad job, and now you have this problem because everybody's relying on that. So I won't go over them, but there's a lot of challenges I find people have with the data mesh in there. And she has in her book that your company should score medium or higher in all these categories to even think about using the data mesh. Well, I mean, how many people here would look at this and say, oh, we score medium or high? Probably none of you. How many can say they're early adopters or tech at core? They are already domain-oriented in there. They're using modern engineering. It just doesn't happen. It's a very few companies. Now, I do see companies building a data mesh, and we have 3 of them here. And my experience at Microsoft, there's a few dozen that are building data meshes. It takes forever. Some of them were building a data mesh before it was even called a data mesh. And they tend to be financial companies because they're already domain-oriented. And a lot of them are in Europe for some reason. I haven't found very few in the US in there. So this is why it's just not adopted much. And this is what I think will happen is people are going to create, if they're going to go down the data mesh route, they're going to build slowly with data meshes. Maybe it's going to be new data, and they'll start with a couple, and then maybe they'll start pulling data out of the centralized solution and creating a mesh from it. But they'll always wind up with having a centralized data solution, because all it takes is that one domain to go, I'm not doing what you request. Then you're going to have to, you can't just say, well, we're not going to use your data. You got to centralize it. So this is what I see customers doing. And even companies that have said, oh, we built a data mesh, and they're out touting themselves. And I interviewed them for the book. And, oh, yeah, we spent 2 years building out a data mesh. Well, how many domains do you have? 12? Well, how many do you want to have? Oh, like 100. I said, you 2 years and you only have 12 domains. And then you ask them, well, how are those domain teams working, that they hired this kind of shadow mini IT teams? Oh, well, we're not doing that. We have a central IT team that's building a lot. I was like, well, that's not going against all the principles. And that's where the problem is. We have those 4 principles. Can you say you built a data mesh if you're only using 3 of the principles or 2 of the principles, or you're using 2 of them kind of half the way? And that's where I see a lot of exceptions. I have a whole long list of a blog post of all the exceptions they have, including the way Microsoft Fabric goes and approaches it. And you can call it a data mesh if you want, but in a lot of cases, it's really not. So to summarize the architectures here, modern data warehouse, I still would say it's a possibility if you have a small amount of data. I deal with very large customers, so they have many terabytes of data. I'm actually in the federal space, federal industry within Microsoft, which is government customers. And you're talking like NASA, who's got petabytes of data. But every once in a while I see a really small agency, and they have, well, we have 20 gigabytes. I was like, well, you can really actually probably just get away with a modern data warehouse, and maybe even skip the data lake if there's that small of a data. But if that's what you have now, is that what's going to be in the future? And a lot of times that's where people mess up. They think, oh, I'll just build something now to take care of the data I have, but it's not going to support other types of data in the future. Data Fabric is still somewhat used for customers, especially if they're doing a migration effort. Because they may have wrote thousands of stored procedures that work against relational database. Those stored procedures would have to be written to go against a data lake house, because that Delta Lake doesn't support all of SQL. So you have to do a lot of rewriting. So in the meantime, they may just go and keep a relational data warehouse and then migrate later off of that RDW. Most customers do the data lakehouse. I say use it till you can't. And if there's a specific set of data that won't fit, that won't give you the performance you need, as an example, then you copy just that data into the relational data warehouse. And then finally, a data mesh. I only see it if you have a really large company that's domain-oriented and already have a bunch of problems. I have a few customers come to me and say, we want to build a data mesh. I go, what's your current pain points? And everything's working pretty good. And I go, well, you're just listening to the hype. If you don't have major pain points, why are you going to spend all this time creating a data mesh on that? And what I wind up finding is people take pieces of the architectures on here, and that's where I say learn all of these architectures, and then make sure you understand them, then go back and look at your use case and take bits and pieces of each of these architectures. Because I've done a lot of architect design sessions, hundreds of them. I don't think I've ever had the same architecture. It's always different and dependent on the customer and their use case on there. And the last thing I'll mention is, if you have any questions on what I talked about, either find me in the halls, come to the industry experts at 1510, I think it is, or send me an email. There's my email address, and I'm happy to have sometimes a follow-up question. You get the special treatment because you've come and visited to this session on here, and sometimes I'll just say, let's get on the phone for half an hour or an hour, and we'll talk through your particular use case and see if I can help you with the architecture. Maybe even do a little bit of whiteboarding for you. So a lot of what I talked about is on my blog, is in my book. If you want this deck, you can email me too, and I'll send you the deck. And hopefully you don't wind up like that drunk guy, and I clarified some of the issues and confusion with the architecture on there. And I appreciate your time, and let's go have fun at the conference.